Today is May the 3rd, 2022, and a couple of 3 weeks back ago I got some of the most beautiful 304 TLs you've ever seen. Look at these guys. Got 4 of them. They're absolutely gorgeous. 304 TL. There's one. The logo is beautifully on each side of the grid pin. There's one. I've labeled them B1, 2, 3, 4. We're going to test them. I have not lit them up yet because I wanted to test them first. I know I've got a big clutter here on my bench, but I've been trying to do a little bit of 40 meter stuff at night. This little Ten-Tech Argosy. I just thought I'd leave the clutter up there. I hear a clean desk is a sign of a sick mind, so I must be okay with all the clutter I got. Yeah, this is a little Ten-Tech Argosy. Does about 30-40 watts, and I'm driving a 30L1 right here. And then I'm running that into this little Collins 180 S1 antenna tuner. Beautiful little piece of equipment. Never been modified. Looks like it just came out of the box. It's even a round emblem there. Some people call it the meatball emblem. But anyway, what this video is about is I thought I would show you how I test out tubes when I get them. A long time before I start building with them, because you never know what you're going to get. Okay, what I'm going to do is these 304 TLs, the reason that these are THs actually, the 304 TH specifies that it's in its day, it's actually a medium mu triode. I guess they call it a high mu triode. There's a 304 TH and there's a 304 TL. Knowing how smart Eimac is and how they label their tubes, it apparently stands for 300 watts of plate dissipation, and it's got 4 75 THs in it. If you can see, there's actually 4 plates in there. There's 4 75 THs inside this, and it's considered a high mu triode. If you were to examine the grid really well, I don't know if you can see it in there, probably not too much, you can see that it's not made out of very fine wire, but the finer the grid structure, the higher the gain of the tube. But anyway, 304 THs, I sure hope they're good. With a regular ohm meter, I did check them out, but I wanted to check them out with a 4-wire Kelvin probe meter, which I have. And I started and I thought, well, maybe I should document this because you guys might get a kick out of it. Here's the meter. It's a Tektronix DMM 4020, and right now I've got them shorted together. Let's see. I'm not be able to see that unless I zoom back out. I got them shorted together here. So it looks like I got about 4 milliohms. I think you can see a lot better. And I realize it's 0.004, that's 4 milliohms, okay? So I thought what I'd do is check them out. If you don't have a 4-wire Kelvin probe, well, and you just check them out with a regular meter, I get some funny readings with a regular meter. And they're all so low, you just can't go there. But look at the way these things are wired. See, there's 2 filaments in there. There's a 5-volt filament on 1 and 2, and there's a 5-volt filament on 3 and 4. So you can light half of it up, or half of it, or you can put the 2 in series here and put 10 volts across it. So it's rated at, if you look right here, 5 volts. If you put the filaments parallel, you'll need 25 amps to light it. But if you put them in series, you need 10 volts and only 12.5 amps. So if you just light 2 of them, you could light it with 5 volts at 12.5 amps or 2. If you put them parallel, you need 5 volts at 25 amps. And I have a transformer over here. We're going to really test them and see if they actually light up. Does it make sense? Okay, so you can do R equals E over I. Checking each filament separately, like I was showing you here on this other one, which shows the separate filaments right here. This would be 5 volts at 12.5 amps, so R would equal E over I be 5 over 12.5, which would be 0.4 ohms. 400 milliohms is what it would be drawing that much current. I don't know what it is cold. It's probably lower than 400 milliohms, but let's see what they are. This is for posterity, and maybe you can use this sometime to check out your own. Okay? We'll start with V1. I got it listed there. And we're going to put the clips on pin 1 and 2. Got to kind of bite them in there good, make sure they make good connection. Can you see the meter there? It measures 0.11. Let's see. Let's lay it down so it's not being moved around. So we get a good steady reading. No, it went down. Okay. Well, there's that. That's 45 milliohms, 44 milliohms. That may be okay. I don't know because it's cold. You see that? 43, 44 milliohms, 0.044. Okay, which one is that? That is V1. Between 1 and 2 measures. See, as you move it around, you got to have really good bites into the meter. Okay, 0.065. Let's write that down. 0.065. This should go pretty fast. Okay, now we're going to go over to pin 3 and 4. 3 and 4, which is the other set of filaments. Remember, this is 2 75 THs parallel. Well, that doesn't look too good, does it? Let's see. Make sure I got a good bite into it. Wow, that one's all over the place. That doesn't look good. 0.96. Well, let's write down what it is. Let's just record it as 0.9. Okay, we'll lay that one to the side. Let's do the next one, which is, well, this one V3. See there? 1 and 2. I sure hope these are beauties. Wow. Okay, between 1 and 2 there, V3 measured 0.63. Maybe that's good. I don't know. 0.63. Okay, so I won't take all day at this. 1, 2, 3 and 4. And that measures 3 and 4 measures. Well, these things are all over the place. 0.17. 0.17. .63. That's a V3. Okay. Which is this one? There's V2. Measures 0.032. 0.032. And that's practically a short, isn't it? Dropping to 0.028. 0.028. 2, 3, and 4. 0.03. 0.029. Well, at least those two are about the same. Okay. And the last one, see, between 1 and 2 of V4, we get, what do we get there? 0.072. 0.072. This, I'm a little concerned about this. This meter is I'm making them bite in really hard each time. Well, that one's about the same too, isn't it? Close. That's not good. Okay, I'll make sure we got a good bite there. There it is, 0.066. 0.066. Okay. So you see what I'm doing here? I'm just clipping it onto the leads, and I'm grinding them in there pretty good so that they make a good connection. Measure 0.068. Okay. Well, that's what we get. So I trust the meter. Okay, the next thing we're going to do, move the camera. I don't want to turn it off. I've got a here's another just a really nice manual or analog type milliometer, very good. But when I did start out using it, but it was all over the place, so that's why I went to the Tektronix digital one. But this thing, I actually trust it too. It's actually quite good. Okay, here's where the real acid tests come in. Okay, I got 5 volts, and we're going to light them up. Which one? Which one's first? What about V1? So I'm going to put 5 volts across 1 and 2, and then 3 and 4. 1. I know that these wires are not big enough for 10 or 12 amps, but that's okay. 1 and 2. Whoa! Wow. Whoa! Well, this is not good. I can see that this one's lit, but look, the filament fell out of that one. Can you see that? It is so bright. The filament's down below the plate. Oh, man. Well, that's the pits. 1 and... yeah, 1 looks like it's lit okay. 1 and 2. And 3 and 4. And there's only 1 lit. Yeah, there should be 2 lit each time. This tube's bad. This one's bad. Oh, that's too bad. Oh, wow. Well, that's 1. Let's see what another one looks like. That's the only one. 1 and 2. Oh my God, look at that. The filaments must be shorted. Oh, this is V3. Oh my God, only 1's lit. I'm going to guess that there's an internal short on it. And that one, well, looks like the filament's falling out of it too. It's lit all the way down to the bottom. I've never seen things like this before. I've never dealt with these 304s. But that one's no good. Well, that's not good, is it? Let's try 4. 1 and 2. Oh, it's got 1. No, it's got 2 lit. Yeah, look at there. That one, maybe this one's good. One's brighter than the other one, but at least 2 filaments are lit. Okay. Maybe I'll get 2 good ones out of it. Okay, now let's go over to 3 and 4. Well, these wires get hot pretty quick, drawing that much current. And, no, see, that one's got 1 filament lit. Just 1. Now, that one's got 3 good elements in it. Yeah, there's something sort of good, I don't know. And last, I don't know. I don't think any of them's going to be any good now. 1 and 2. 1 and 2. Well, got 2 filaments lit. They actually look kind of healthy, I guess. Yeah, 1 and 2. And 3 and 4. Oh. Well, it looks like the filaments may be good in this one. And those 2 are lit. Yeah, and if you want to put them in series, you can you put them like this, and then you have to short these two together. Of course, it's going to just be half lit, because you have to put 10 volts across it to light it fully. But if you want to light it with 10 volts, and then you would short them together like this. I think they should probably light. Oh, they do. Look at there. That's beautiful. They're only half lit, but at least they are there. This one looks like it might be good. Well, that is very sad. That is so unfortunate. Well, it looks like I got one tube out of 4. Well, they get hot pretty quick. Yeah, I want to show you a 75 TH, and I'll show you what this thing right here is made of. It's made of 4 of the 75 THs. I got some up in the attic. I'll go get one. Okay, here's a genuine 75 TH. Let's light the filament on it. It will be on, actually not sure. Yeah, I can hook it up. Right there. Let's don't do that. Let's don't short them together. There we go. That's a real 75 TH. So it's got 4 of those little beauties in there. Isn't that neat? Well, darn. That's not what I wanted. Well, let me think about this just a second. Well, there's not a lot left to show here. I will show you here this 75 TH. If we clip this guy on right here to its filament, we measure its filament. We measure this. We know this is a good one. It measures about 99 to 197 milliohms. I think you can see that okay. Right up here, 98, 99, 100 milliohms. And if we be careful, I don't drop it. If we spin it around here and we measure it on this beautiful old Simpson, we get okay, I'm working on it. I'm clipping it on here. We get we get same thing. That's on the 250 milliohm scale, 0.25 ohms, and it measures. As you can see, I want it to focus. 100 milliohms. So that's what the 75 TH should be, and since the since the 304 TLs and THs are 4 of those, 2 of them parallel, they should actually measure about 50 milliohms. 50 milliohms, and a good one measures on this one. If I can keep from banging it around so hard. That I'm just trying to. Is that right now? 1 and 2. So it's 2 parallels, so instead of 50 milliohms, it should measure. Let's see what it actually measures on this guy. Actually, it measures even a little bit less than 50 milliohms. It measures about 35 milliohms, about 0.035 ohms. And the good one we got, let's see, which one is the V2? We'll measure 0.28, 0.29, so around 0.3 or so. Well, that is that. I am very disappointed But there's nothing I can do about bad filaments. Let me show you something that I use here quite often, and it's really cool. You might consider this. I use a magic marker to put these on here. Just a standard old magic marker. But I use a mixture of this stuff right here, which is the 99.9% or something. Yeah, 99.9% pure isopropyl alcohol. You can buy it in a lot of places. And acetone. I mix it 50-50. 50% acetone, 50% pure alcohol. Not that stuff you buy at the drugstores. And I make this. This is, see, I've acetone alcohol. I've relabeled it, and I put it in a spray bottle. This is cool stuff. It really is. And I'll show you how effective it is. Let me squirt a little bit on the rag here, and how well it cleans up. You can see that V2 right there. Watch this. Gone. Isn't that neat? And it evaporates instantly. So I use that for. It's a whole lot cheaper than using than using those expensive tuner contact cleaners. And one more time, I'll show you this little radio. I've been having a lot of fun with it lately. I think there's somebody on there now.
Come up with ideas. That's what it's all about.
Yeah, that's a receiver. I'm on 40 meters. Driving this little 30L1. And again, I've already showed this now that I think about it. And that pretty little antenna tuner out there. Well, there you go. I hope you ladies and gentlemen out there enjoy this. And thanks for watching. Take care.